Never mind.
Never mind. Can't. Taylor, you gonna take notes today?
I'm really tired. I early to do chores this morning,
What time did you get up, Tate?
like 6.
So did I, Tate.
You did some chores?
Yeah.
Wow. Was that like mandated?
Yes.
If you want to eat in this household, you will do chores.
No, every time I don't do chores, my dad takes $30 out of my account.
Nice.
Absolutely.
Every time I don't do the dishes, he takes $20 out of my account.
That's so, like, smart.
Yeah.
Good work, Father Rob.
You want me to steal from me whenever I do something wrong?
Does he give you an allowance at all?
No, I have to make my own money, dude.
The amount of money though that parents provide, he's not stealing from you.
Is he exasperating you too?
I don't know, I don't understand. Like, I have no problem going to work and working Taco Bell, but when I get home and there's like chores, I'm just like, no.
So then you have to pay somebody to do your chores.
Yeah.
Yeah, so you can hire somebody to do your chores.
For, like,
Tate,
$10.
you can hire me for 15.
You'll come do the dishes.
You only have to pay 15.
Hey Rob, hey Lauren, just coming to do your dishes.
Yeah. I'll do it for 15.
While Tate's like gaming. Good job, Nick.
15 a time, Tate.
That's crazy.
I'll do it, Tate.
I don't think they'd let that happen. Like,
Did you just show up at Robbie's house yesterday?
Oh yeah, that's what Rob said.
yeah, you give me this thing, and also a t-shirt.
That's sick.
Yeah.
Wait, Robbie said that he,
Do you just come
Well, you
unannounced?
yeah,
No, he asked me to come over.
that's not what he said. He said you just spawned in his room. You came in the back door and spawned.
No, he said, hey, come over, I have something to give you.
Oh, Tate.
Robbie was telling me how he needed to be there for you guys to hang out or something.
No, he needed to be there in order for us to be able to work on our REACH project for
Yeah,
Kendall.
my parents would let just us work.
Which I felt bad for Robbie because you only really need 2 people, but whatever.
Okay, if you have a infinite series that looks like this, sure, this is fine. 2 plus 2.01 plus 2.02. What kind of series is this going to be?
Infinite.
Infinite, and then very good. Arithmetic or geometric?
Arithmetic.
Arithmetic, right? Because we are adding 0.01 each time. Will this have a sum?
No.
Will it have no? I mean, the sum is it just keeps getting bigger and bigger, so it goes to infinity. Therefore, there is no sum. So if you have an arithmetic infinite series, so it's arithmetic, it's infinite, and it's a series because you're adding, there is no sum for an infinite arithmetic series. So no sum for this. Now, what if we have, let's go with 1 plus I don't know, I'm struggling here. 2 plus 4, that's fine, plus 8. What's this? This is infinite. And then geometric. Is this going to have a sum? No, because it keeps getting bigger, right? And you're just adding bigger terms, so no sum. Okay, then what happens when we have this 1/2 plus 1/4 plus 1/8 plus 1/16 plus dot dot dot. This is arithmetic or geometric?
Geometric.
Geometric.
Kind of.
So we are adding terms together, right? Question is, will there be a sum with this?
I mean, technically no.
Yeah.
Technically, yes, surprisingly enough. Because based off of yesterday, if you recall, when we talked about the limit as n approaches infinity of 1 over n, what is the value of 1 over n as it goes to infinity? Not its value, but what it goes to. It goes to what? 0. So that goes to 0. So yeah, it doesn't quite hit 0, but essentially you're adding 0 in the end. So in this case, with this, the same concept is eventually way out here, you're going to be adding 1 over infinity, right? Therefore, 1 over infinity is essentially going to 0. So you're really adding, it's like adding 0 in the end. Therefore, there's this whole host of numbers that add up to something. And it gets really, 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 really close to that value. It never actually hits exactly that value. So technically, maybe there is no sum. But since it's going towards that value, we say there's a sum. And so that would be, in this case, the sum of this goes to something specific. And we have a little formula for that. So you don't have to add 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32 and keep going. So this is the, this would be 1/2 to the n, right, is what you're doing. That would be like an equation for it. The common ratio is 1/2. So when you have an infinite geometric series, and the ratio is greater, absolute value of the ratio is between 1 and -1. It is t sub 1 over 1 minus r. Your formula is t sub 1 over 1 minus r. Okay? Now this is for an infinite geometric series only when and we discussed this yesterday, after your ratio is less than 1. So if the ratio is greater than 1, then it's just going to keep getting bigger and bigger and bigger. Or if it's or it could be, let's say, when I say it's greater than 1, if the ratio is absolute value of r is greater than -1, absolute value, greater than 1, there is no sum involved. And absolute value of r greater than 1, we could rewrite that as x, or r is greater than 1, or r is less than -1. So the only time you're going to have a sum of an infinite geometric series is when the ratio is a fraction, less than 1, or greater than -1. And then you just plug into that. Now, if this is the case, they use this term, if you have this, there's no sum, or they say the series diverges. And that's like a mathematical word they use, diverges. Meaning it doesn't converge to one value, it diverges to another value. So let's go ahead and find, so we have, do a few examples from this, and then we will be done. Let's do this. Find the sum, and let's go, if you have 24 minus 12 plus 6 minus 3 plus ... So one thing, again, you test is, if it's arithmetic, immediately there is no sum. Yeah. If it's geometric, it might have a sum if the ratio is a fraction. So these are probably all going to be geometric. All right, so we check, is it geometric? -12 over 24, -1/2, 6 over -12, -1/2. So yes, it's geometric, and then is the ratio absolute value less than 1? Sure. Hello.
I have a visitor
Oh,
that maybe you recognize.
John.
should I recognize?
You had him as a student?
He was in Mrs. Deerfield class, but I didn't.
Oh, is this Mr. Whittemore?
It is.
Yes, it is.
Oh wow, the Mr. Whittemore.
Yes.
Yes.
There's not a whole lot of us here.
Wow,
We're here
good to
when
see
he was
you,
here
sir.
for 2 years, yeah.
Band man. You didn't you teach band?
No, Kim did. But
Your wife
yeah,
did.
yeah.
Most excellent. I haven't seen you in,
I came back a couple summers ago, but other than that, I haven't been here since.
but I haven't seen you
Yeah,
in
30 years.
30 plus years. It came back to me. That's pretty impressive.
So you're gonna come back to us.
I'm working on it. I'm working on it. And
Forgive me
yeah.
for all of the, being such a rebel in 6th
Yeah,
grade.
I have nothing but great memories of your family.
Oh, of my family, not of me.
Yeah.
I will greet my mom.
Yeah.
Yeah, she's living the
It's my heart
retirement.
to see you on when I pull up the website and see
Oh,
all your name.
yeah.
I'm like, this is good.
Yeah. Where are you guys at?
Wichita.
Oh, in Kansas.
Yeah.
Okay. Teaching over there?
Yes, I am.
Okay.
Yep.
And Kim is.
She teaches for public schools. We've been divorced a long time.
Oh, okay.
But,
Very good.
man, so, yeah, me too. But,
Yeah. So you're in Wichita.
yeah,
Okay.
at a very similar Christian school.
Oh, okay.
Yeah.
Very good.
Teaching part-time, administrator part-time, and
Okay.
well,
Yeah, doing a lot of different things.
Yeah.
Cool. And you're back in Missoula just.
came for the jazz festival. They're having an alumni
Oh,
deal, so
okay.
yeah, helping for that.
Nice. And then coming
Yeah.
through the school.
So yeah.
Yeah, a few leftover
Yes,
faces.
I know.
The Hawkins are here.
Yeah, John and Wade bought our house when we left, so.
Oh, they did? Oh.
Oh yeah, they're in Helena.
Yeah, on the field trip, yeah.
So, okay.
So what are we learning in here?
What are we learning?
Yeah, what are we doing?
This is a math room.
Oh, nice.
Math. Yeah,
Excellent.
math.
And they love it.
Always.
Yeah.
Come on.
Yeah, we love.
There you go, that's it.
Which math class is this?
Pre-calc.
Pre-calc.
Oh, awesome.
A couple kids are in Rugers in Mississippi.
Yep.
And then Carmody's in
Phoenix.
Phoenix. Yeah, a couple
Phoenix.
kids are gone.
And I see how sad you are for spring break next week.
Everybody's angry.
I started mine early, so yeah, we're off next week too.
Oh, nice. And you started yours early.
Yeah.
Very good.
Mr. Elson, are you recording your math lesson?
I am.
You are. Is it for the students that aren't here?
And those in our area. So they'll have to ride through a little bit of
Yeah.
They put it in 2 times speed anyway.
Yeah, they did it 2 times. They speed it up. So
You sound like a chipmunk when you laugh in 2 times.
thank you. Take that as a compliment.
Wait, did you notice that?
So, well, yeah, great to see you. Yeah. Yeah, those are long days, long years ago,
Good
10
memories,
years ago. Yeah, I was in Doreen's class,
Yes,
so.
and I had a girl come from Great Falls a couple of years ago as a senior, because her dad was chaplain for the Air Force Base up there. So and she had to read that.
Oh, is Doreen still teaching
Yeah,
over there?
I was, I think she's retired now, but she was then, because she had her after Christian school.
Because I haven't seen them in a few years.
Yeah, so that's like small world.
Wow, and then she, yeah.
And I grew up in Great Falls, so we would swap Great Falls stories.
Oh, nice. I didn't know you grew up in Great Falls. but
Great.
I probably wasn't asking you any questions as a 6th grader.
Yeah.
Any get to know you questions. So,
Yeah.
that's great. Well, good to see you.
Good to see you too.
So, yeah, welcome back to
Alright.
the brief window of time.
I don't wanna do part of these.
Yeah, these guys are really eager to learn. Look at this
We're
guy in
eager, we're
front.
eager to learn. Back to math.
Tate,
Yes.
Tate
Yeah.
just can't wait. Well, good to
I
see
know,
you.
something
Yeah,
like
me
the
too.
first grade
Well,
years.
yeah.
right?
Thank you guys for your time.
See you later.
Yep.
Well, I'll watch the lecture on 4 times speed.
Watch it on 4 times speed.
I wish that was.
Okay, let's do this. What's our ratio?
Did you like him as a teacher?
-1/2.
I didn't have him as a
You
teacher.
were like,
Oh, well.
He was, there's 2 6th grades and he was the other 6th grade teacher.
Mr.
I nailed it 30 plus years ago.
Yeah.
That's impressive.
Then,
that's why you were like,
Should I know you?
and what's her name?
I was-
Oh, awkward.
and we're divorced.
So, okay, ratio, what's our ratio?
-1.
-1/2. Does that fit that it's less than 1?
Yes.
Absolutely, you bet. So then you just plug it in the formula, that's it. And the formula states, where I put it, S is equal to T sub 1, so 24, over 1 minus a -1/2. And so therefore, you will have 1 plus 1/2, so 24 divided by 3 halves. comes out to be
16.
16. Okay, so some of them are just that easy. Then you'll have ones like this. What is the value of x? What is the value of x if the series, let's do this one, 1 plus 2x plus 4x squared plus dot 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 converges to 3/5. So when we say the series converges, the reason why we say converges means it goes towards. Therefore, it doesn't actually, just like we said, this value, the sum is 16, does it actually hit 16?
No.
Like exactly, no, but it goes towards 16. So that's why we say converges versus equals, if you will. I mean, in the sum formula, we say 16. But the idea is that it's converging towards that, towards 3/5. So what is the value of x if the series 1 plus 2x plus 4x squared goes to 3/5?
So 1 over 1 minus 2x.
1 over 1 minus 2x?
Yes.
Where are we getting 1 over 1?
1 is the, yeah. What? No. 1
No.
over 1 minus 2x.
Okay. So you're, for the
Three.
first term is 1 over 1 minus 2x, because the
Equals
common
3/5.
ratio is 2x, is equal to 3/5. There we go. So we cross multiply. 3 minus 6x is equal to 5. And then negative 6x is equal to 2. X is equal to negative 1/3. Okay. Then you will get one that says, for the infinite geometric series, find, A, the interval of convergence. We'll talk about that. Find the interval of convergence and the sum. And then B, the sum in terms of x. Okay? So with this one, you will end up, let's take a look at this one, 1 plus x minus 3 plus x minus 3 squared plus dot dot dot. So in this case, they don't tell us that it goes to a value like they did in this previous problem. They said, hey, it went to 3/5, so then we just set it equal to 3/5. So the interval of convergence, we know that a series, infinite geometric series, will converge if this is happening for us right here. Okay? So if the absolute value of the ratio is less than 1, it will converge. In the case over here, we don't know the ratio. Well, we can find the ratio, but it'll just be in terms of x. So when it says the interval of convergence, that's going to mean there's a value, there's more than one value for x that will allow this series to converge. Because as long as your ratio is less than 1 and greater than -1, it will converge. So all we do is define the interval of convergence. An interval would be between, x is greater than 3, less than 7 or something. That's an interval. So in this case, you just find what's the ratio up here. The ratio is x minus 3 over 1, right? Or x minus 3 squared over x minus 3. So the ratio is equal to x minus 3. To find the interval of convergence, we simply state that we know the absolute value of that ratio has to be less than 1. And then you use your absolute value knowledge with inequalities and state, right, x minus 3 is less than 1 and greater than negative 1. Then we add 3 to both sides, and you get out 2, and then you get out 4. And so the interval of convergence, that's your interval of convergence. As long as x is greater than 2, less than 4, it will converge. So 2.1, 3.79, those values would make that series converge. Anything in there would work. So then they state, find the sum, just let it be in terms of x. So we go to our sum formula, right, which is right there. We take t sub 1 over 1 minus r. And so s is equal to t sub 1, which is 1 over 1 minus the common ratio, and which is s is equal to 1 over, is that going to be 4 minus x? Like that. And that's all they're looking for is for the sum. It'll be in terms of x. Okay. So then we have a couple more things to cover. Maybe just one more thing to cover, and that is, if you have, so for the series, find the first 4 partial sums. Okay. So for this series, find the first 4 partial sums, and then so that's going to be s sub 1, s sub 2, s sub 3, and then s sub 4. So you're not finding t sub 1, you're not finding the term, you're finding the sum, and then you're going to suggest a formula, and then find a formula, or they say suggest a formula for s sub n, like that. Then you find the sum of the infinite series by evaluating the limit as n approaches infinity. So let me just put these up here, and then we can talk about all the stuff they want you to do. 1 over 1 times 3 plus 1 over 3 times 5 plus 1 over 5 times 7 plus plus 1 over 2n minus 1, and then 2n plus 1 plus . Okay. So what they want you to do is, this is the series, and they want you to find the first 4 partial sums. Partial meaning you're not finding the sum of the entire thing, you're just finding part of it. And so s sub 1 should be really easy for us.
Or 1/3.
Yeah, the sum of the first term is just 1/3. Because you only have one term, you take that, and it's 1/3. Then the sum of the second term, the sum not of the second term, but the sum of the first 2 terms is going to be 1/3 plus 1/15. So what's 1/3 plus 1/15 give you?
6/15.
2/5.
6/15, which would come out to be 2/5. Okay? So then s sub 3 would be, right, this one plus this one plus this one. In other words, you can take s sub 1 or just s sub 2 and add it to s sub 3. So 2/5, because that whole thing is 2/5 plus 1/35 comes out to be 3/7. And then s sub 4 is going to be 3/7 plus, what's the next one going to be? It's not written, but what's this one in here going to be? 1 over
7 times 9.
7 times 9. So 1 over 63 plus 3/7 gives us 4 ninths. Okay. So now those are 4 partial sums. What they're wanting you to do now, this type of math for some formulas of series ends up getting used in Calc 2 when they're doing power series and finding different types of sum series. So this like you probably won't see, I mean you'll see limits again, quite a bit of limits, but you won't see limits of series unless you get to Calc 2. So then the next thing they want you to do is find the formula for S sub n, meaning don't look at this because this is not S sub n, that's just term 1, term 2, term 3. They want you to find a formula for S sub n using these numbers. So you can think of this as like your sequence, this, and this. It's not arithmetic, it's not geometric, it's neither, so how do I find a formula, or I just need to find a formula for that.
Wasn't it?
It's a geometric, or it's a arithmetic on the numerator,
Okay.
and
It's just you're
arithmetic
adding 2
on the,
or you're adding 1 to the
denominator.
top and 2 to the bottom.
Okay.
so just put the, can you just put the,
So just,
arithmetic sum formula on the top?
yeah, can't you just.
Well, it's not geometric on the bottom.
No, it's arithmetic on the bottom too, but they're separate.
Oh, arithmetic on the bottom.
That's
Okay.
Do you
What?
understand?
You could do, yeah.
You do n plus 1 over.
That doesn't work, because then the top one would be 2.
Oh, yeah.
So if you look 1, 2, 2, 3, 3, 4, 4. So it's just gonna be,
Yeah.
yeah.
So it's 1
Oh, so
plus
it's just n.
1 plus. Oh yeah.
Or what are you saying? 1 plus
1 plus
n minus 1 times d, which is 1. So it's 1 plus n minus 1, which is just n. So yes, that works to do that, and you're just gonna end up with that. I was just trying to look at it like, right, 1, 1, 2, 2, so you're just doing S sub n. Alright, on the bottom, you could do the, like Riley, you're stating, can I just do the formula? Sure. So for the bottom, the first term is 3 plus n minus 1 times the difference of, what's the common difference on the bottom? 2. And you could simplify that out, right? So it's 3 plus 2n minus 4.
So 2
Or I'm sorry, minus 2.
So
And
2
so
n plus 1.
2n plus 1 on the bottom. 2n plus 1. Okay, so there's your formula for that. And then what they want you to do is evaluate the sum. So they want you to they state this. So they want you to find the limit as n approaches infinity of s sub n. So now that I came up with a formula for it, n over 2n plus 1, we could find the limit. So as you go to infinity for n, meaning there's an infinite number of terms that you're going to add together. So we're finding the limit of the series. It'll be.
is this where you times the top and bottom by 1 over n?
Yes, that is. You're going like so. You're going to find the limit of 2n plus 1. So what's the limit of this? And you can divide everything by n. This is from yesterday's work, and you end up with 1/2. So what we did is we took a series up here, 1/3, 1/15, 1/35. And in this case, like the 1/3 plus the 1/15 plus the 1/35 plus dot dot. This is it's not arithmetic, right? It is. Is it geometric? One 1/15 divided by 1/3 gives you
3/15.
3/15, which is 1/5, and then 1/5,
3, 7.
1/35 divided by 1/15, so 15 over 35, which is going to give you sevenths. So do these match for a common ratio?
No.
No, doesn't match for a common ratio. So the point of this was to look and say, okay, well, what's the sum of this? Well, it's not geometric, so I can't plug it into my formula, right? But you could take that, find partial sums, generate a formula for it like this, and then do the limit as the n goes to infinity. So you're finding an infinite amount of partial sums, which means you're finding all the sums, and you're able to find a limit of
Well,
that.
how'd you get 1/2?
You multiply the top and bottom by 1 over n.
So yeah, 1 over n over 1 over n
So the top is just 1,
over 2 plus 1 over n.
which is
Whoops.
0.
And then as n goes to infinity, that goes to 0, and you're just left with 1.
Oh.
That's from yesterday's.
Yeah.
Yeah.
I used to do that to him all the time.
What is that?
A marker.
Are you gonna draw my face?
I already did. You've been asleep.
Let me see, Tate.
No,
It looks
you did
good.
not. You did not draw my face.
Kate, can I see?
I was so crazy.